higher order linear differential equation with constant coefficient. So the example is solve d square y by the dx square minus 2 dy by dx plus y equals to x e raised to the power x sin x. This is the second order equation. Therefore, it is called as the higher order equation with constant coefficient. We are saying it is 1 minus 2 and it is 1. Now, first job is to find out the complementary function for this differential equation. So for that we write out the given equation first of all into the symbolic form. For symbolic form we just take the d as a ddx. So this, if we take the d as ddx, this will be nothing but the d square. It will be the d. This is plus 1. We have taken the y outside, y common, equals to x e to the power x sin x. After that our job is to find out auxiliary equation. I just replace the d by m. It is m square minus 2m plus 1 equals to 0. Now this is nothing but what? M minus 1 whole square. The roots are it is 1 1. The CF can be written as for the equal and real root. It is c1 plus c2x. This way we take the constant into the root is 1, so therefore it is the power x. We have written. Okay. Or you can multiply this x with the c1 or maybe with c2. That's one of the arbitrary constant we have to multiply that particular independent variable. It is x. Now we find out the pi. Dx 1 upon d square minus 2d plus 1 x e to the power x sin x. Now here which case will apply here? We cannot apply the case of exponential function, that is e raised to the power x, because xn and sin x is present here. We cannot apply the that is case of sin x or cos x, because again I say it is x e to the power x is present. We cannot apply the case of x to the power m as well, because x e to the power x into sin x is present. So what we do here, we will apply the case in which the exponential function is multiplied with some function of x. So in that case what we do, I take this e to the power x to the left. Okay, इसको left में लिया. Then simultaneously I replace the d with d plus 1. Actually coefficient of x is what it is, 1 here in the exponential power. So that's why we are replacing the d by d plus 1. Again replacing d by d plus 1. Okay. Simplifying the quantity, that is a plus b whole square, this is simplified, you will get just a d square. So 1 by d square means it is a integration 2 times with respect to x. Okay, so you can do the integration 2 times with respect to x, or again we have the one more case to simplify this particular fraction. तो इसको हम कैसे कर सकते हैं और simplify? We are having one case, that is 1 upon function of d x into v. Here we are having x into sin x. So we are having the formula for that. It is what? X 1 upon function of d into v minus, take a derivative, write down here, then take a square of this, into it is what? V. So v is what? Sin x. Just put the v as sin x. So this is what? We put down here x, then 1 by d square, this is v, minus, take a derivative, take a square, then into again v, that is sin x. Now 1 by d square is here, so sin is here, so we can apply the here, we can do the integration 2 times with respect to the x, or otherwise we can apply the case as well as जो हमने दिखाया for the sin x. So I will replace the d square by the minus 1, because coefficient of x is what it is, 1. In sin functions we replace the d square by what is it, minus of a square. So a is what, 1 square is 1, then multiplying by the minus 1 I get that is what, minus 1 into sin x. Again same case here, d square is replaced by minus 1, then minus 1 square is plus 1. Okay, now 2d, d means derivative with respect to x. Take a derivative of sin x with respect to the x. The derivative of sin x is what, cos x. So it will be a cos x here then. Okay, that is written here, into it is minus x sin x. Minus sign we have taken outside, it is a minus e to the power x. The remaining thing we have written then, it is x sin x plus 2 cos x. Then complete solution is given by, what is it, y equals to cf plus pi. That is a particular, that is complementary function plus it is particular integral. So this way we solve the example whenever we have the function of this type, x e to the power x and sin x. Okay? So that time just take the e to the power x to the left, and then for the remaining x sin x we apply that case to get the pi. Okay, thank you.